Good evening, everyone.
Good evening, sir.
Yeah, so we'll be waiting for 5 minutes maybe, and then we'll start. Very less people have joined until now. Okay.
Sure, sir.
Till before that, you can just log into PeerTech, joinpt.com, and get ready. Okay, is my audio clear to all?
Yes, sir.
Yes,
Clear.
sir.
I think the code is over here, right in the center. It's LNH. I'll just type it in the text box. Just a second.
अभी पता है कि हम लोग के गड़े सड़े बेचना है, हम थोक के बेचने वाले थे। पाँचे किलो कर दिए तो कोनो नामरो तो ना
Chandar भैया, please mute yourself.
खा लीजिए अब।
Okay, so we'll start now. I think enough participants have joined in. So how many are new to peer deck, or everybody has logged in till now? Anybody who's left till to join into peer deck? Okay, so we'll move to the first question. Basically, it will be the same style where we'll be getting out in one main question and there will be preludes to the same question. So we'll step by step keep solving it, and finally we'll solve the main question. Okay.
Okay, sir.
So basically, same way will according to the questions, we'll be giving out some time, and you can fill out your responses from join PD. Okay. So this is the first question. The basically a part to the first question. You all can start.
So this question was not updated in peer deck session.
You can't see this in PRD. It's there, right?
It is there. Just need to refresh the page.
It is there, sir.
Okay.
Visible.
Sir, where we give the answer, because there is no any option for giving answer.
I think there will be a text.
Yes, sir.
No text box, sir.
No answer option, sir. Yeah.
Okay. For this, there is no option available, right?
Yes, sir.
Yes,
not
sir.
even text box to fill it.
No.
Yes, sir. No.
Okay. Just type the answers in the chat box. We'll see. Okay. But don't type it now. If you are finding the answer, keep it up to you. Once I'll tell you, just type everyone. Okay. If
How
you're done
to
with,
how to get the link for the joint PD? I'm
just
not able to.
just log in with joinpd.com, and on the top right, I think you will find a code. I think even somebody has even mentioned it in the chat box.
Okay.
Sir, code is not working.
For others, is it working?
It is working, sir. The first letter
Yes,
is
sir.
first
Yeah.
one is L, not I. That is the problem.
Okay, I think then there may be some network issue from your side. Just refresh it once.
No, sir. The people get confused with that first letter. That is L or I. First letter is L.
Sir, can't see the code in the screen. Where the code is?
It was there. I'll just type it. Just everybody, you can take it from the chat box. Okay.
I just joined, so this is not in chat box. Can someone please post it again?
Yeah, it has already been posted. Just take it from there and log in. Okay, how many of you are done with the answer?
Done, sir.
Done, sir.
Done, sir.
Okay, we'll move to the chat box once. Okay, there's only. Can you just all type it in the chat box? Like what answers have you got? Okay, 0.38, 0.3 everyone. So any one of you, how to just approach it? Just anyone, if you would come to, if you want to explain it.
5C1 by, so there are 5 balls in the urn which are blue, and in total there are 13 balls.
So the
fi-
probability we have been asked is for the blue ball, right? And we are choosing one ball, correct?
Yes, yes, sir.
So you all are saying it would be 5C1 divided by 8C1.
No, sir.
No, sir, 13C1.
Sorry, 13C1, correct.
Yeah.
All agreed with the same?
Yes, sir.
Sir, also we got 5 by 13.
It will be same,
Uh,
right? 5C1 is same 5.
Yeah. Yeah.
Okay, so that's the same. There are 5 blue balls and white red balls, 5 by 13, or you can do 5C1 divided by 13C1. That is the total possible cases, correct?
Yeah.
Okay, so this is an intellect question only. Over there we were collecting only one ball. Over here we'll be collecting, picking up 2 balls randomly. Okay, and there's a constraint given. So what's the probability of fulfilling that constraint?
Sir, just want to confirm. So we have left the periodic session, right? We can close that.
No, just be in that. I think the first 2-3 slides. I think this first question, the options has not been updated. Later questions, I think they are updated. Okay?
Okay,
Sir,
sir.
question not updated. Question not updated. Same
Sorry?
question. The question not updated.
No, just read it properly. On the right side, the question has been changed.
No.
It will
Over there,
take some time.
Yeah, it is updated.
yeah. So over there, the question was we were picking up one ball and what is the probability that it was red? Now we are saying that we are picking up 2 balls randomly and what is the probability that the first ball is red and the second ball is blue? And you have to also consider about this without replacement order of the order. Does it matter or not? Try to find it out.
So actually, I can't give the responses because I'm unable to join the session. So what is code for this session, sir?
I think it has already been mentioned in the chat.
Okay, I'll see.
You all can see the updated slides in the peer tag, right?
Yeah.
Okay. I think only the issue is with the okay. I think now you should have an option to pull.
Yeah, okay. So sorry to interrupt. I have updated the slides. You can now see you can type your responses there now. Okay.
Oh, sir, our slides are still stuck on slide number 4. If you can, that.
What is the question you can see now?
Sir, in peer deck.
Yes.
Sir, it's the same question, choosing a ball or 2
I
balls.
think you have to refresh it. I think others can see it, right?
I refreshed it.
Sir,
Yes,
I
others
also refreshed it. I
can
am
see.
putting the first question.
And then it would be network issue from your side because
Even I can see the first question of yours.
First question in the peer deck, sir. It's not away, but we can see in the Zoom meeting if we come to that, we can see the new question.
okay. Others you can see it, right?
No, sir.
Yes,
Sir, on the
sir.
peer deck, it's the question number 1 is available to everyone.
The question is an urn contains 5 balls.
In peer deck, we are not able to see, but in Zoom platform, we are able to see.
Okay,
Yeah.
I'll stop the peer deck. We'll go just sharing the slides for Zoom. Okay, you can answer it through chat box. Just give me a second. Okay, I think all of you, can you just log out from peer deck and log in through this new ID so that I think it will work out now for others seeing the questions. Can you see the new ID? WNANLZ?
Yes, sir.
Okay.
Sir, how to join this join PD login? How to log in the join PD? I have never done it. Actually.
Just Google it, joinpd.com. You'll be asked to
Okay.
type a code.
Okay.
This was the question where we were stuck. So can you all see now this new question, the second one?
Yes, sir. Yes,
Yeah.
sir.
Okay.
Yeah, sir. Also the option are come.
Okay. I think we have 33 in the meet. Others also, can you please join in to join PD? 50% have joined in. Anyone still trying, or we'll move to the solution part?
So in PD.com,
Done,
it's
sir.
not working.
Just refresh it. I think it's now working for others, right?
Yeah, working.
Sir.
Okay. Okay, so anyone still trying, or we'll move to the solution?
Done, sir.
Okay. Almost for 2.26. So basically what we'll be doing for this question, let me move to the solution. So as we are saying, the first ball has to be a blue one, and red one, and the second ball has to be a blue one. So what do you think, are these events independent or dependent or independent events? Let's say the event first ball picking up first ball as red, let be the event R, and second ball picking up as blue, let the event be called as B. So we are trying to find out R intersection B, right? When we are saying that first ball and the second ball has to be blue, red and blue respectively, right?
Yeah.
So do you think it's an independent event or a dependent event?
Dependent.
Why do you say so?
Dependent event, sir.
Independent.
Who is
Sir,
saying
it is
independent?
Dependent, sir.
Okay, who is saying independent? Just tell me the reason behind it and why you are thinking it's as dependent. Tell me the reason. Any one of you.
So reason for dependent is if one ball is removed first, then for the second denominator becomes 12 one less.
Okay, yes, the practical is a right argument, but I want you all to focus on one statement in the question that was given. If you see this without replacement, right? That makes us to think this way, that once we are picking out one ball, then we won't have that option for the second pick, right? So that's why it
Yes,
becomes an dependent event. So be careful about the whatever the wordings are there in the question. All, can you please mute unless you are talking? Okay, so that's why if it would have been an independent event, then we would have done R intersection B as probability of R into probability of just B. But as these are dependent events, as we are picking up the balls without replacement, so the second part, according to the formula, we know that it will be first probability of R into probability of given R, what is the probability of B, right? So anyone, any doubt in this part?
No, sir.
Okay, so we'll move to the next.
Sir,
How do we prove, sir? Like that Hello.
Sorry, I didn't get you. Yeah, can you repeat?
How can we prove that actually E intersection F is equal to probability of E into probability of F? Can we prove that way? No.
Probability of R into probability of R intersection B, you are saying that how it is probability of R into probability of B, right? When it is independent.
No. How can we prove that they are not independent?
That is, I said, from the question you have to take the clue that it is even without replacement. So when you are already picking up the first ball, for the next pick you won't have that ball, right? Whatever ball it may be. So you're automatically the total option or the sample space from which you can pick up the ball becomes 12, right?
Exactly.
So that's why you can conclude that these are dependent events.
Oh, okay.
Sir, in the denominator, if we would have done 13C2, so that it becomes wrong, but that also says the same thing, that we are selecting any two balls. So then why is that?
No, when you are taking it is, you are not considering the dependency, right? For conditional statements you can't do it that way, because over here two events are dependent on each other, or there is a condition given that already the first ball has been picked as red, and then you are going for the next option. It's not that we are picking both together and we are saying that what is the probability that the first ball is red and the second ball is blue. Over there it would have been 13C2, because at that time we are considering that for the means at a time we are picking up two balls, right?
Yes, sir.
It's
Yes,
one
sir.
single event.
Yes, sir. I get that. So can you show the question again? Okay. Okay, sir.
Okay, we'll move to the second question. Can you all see it? The second question is visible to all, right?
Yes, sir.
Okay. This you are able to type out your answers, right? Anybody, any doubt with the approach? If anybody is not getting it, you can ask. But everyone just try it. Don't wait for the solution. Give it a try. Unless you try, you won't get the. You won't understand how to approach this kind of questions. Can anyone tell like what concept are you going to use for this solving this question?
Sir, I'm using tree diagram.
Okay.
Law of total power.
Okay. Law of total probability.
Yes. And then subtract from 1.
Okay. You can just find out the solution. Others were not haven't found out how to solve it. You got an hint already that it's you have to find out total probability. Okay. We are using law of total probability. So break it into cases and you can solve it.
Sir, may I ask a question while others are solving?
Okay, yeah. Is it related to this question?
No, previous question.
Okay, then please, can you just be till the end
Yes,
of the
sir.
session?
Yes, sir,
Okay.
yes.
Only 8 responses still no, guys. Others, please try. If you're stuck somewhere in this question, you can ask. If you're not understanding how to approach it, if there is something conceptual related, you're not able to crack it for this question. But please give it a shot. Give it an whatever you
Sir,
feel.
I'm not able to do it. How to proceed with this?
Okay, can you tell me what is law of total probability? Like, what's the formula for it at least?
This is A intersection B is equal to A what is given by this kind of formula
No, no,
talking
no.
about.
For example, the probability of A can be given by probability of A intersection B. Sorry, A intersection R plus probability of B intersection R. This way something means you are trying to find out two events and what are the possible cases. For example, I can say that there are two machines and the probability of each machine producing a defective item. It's there's some probability X. Okay. Now I'm telling what are the possible ways you can find that the item which you're selecting randomly, it's a defective item. Now I can get it either if I'm going selecting first machine A, and then there's a route that I can find out it's a defective item, or again there's a possibility that I will select machine B and then I can find a defective item, right? So this way we are trying. So my probability I'm trying to find out is for total defective items. That is probability of, let's say the event let it be D. Then probability
That's I got it that I have to find out the total person who are left-handed. Then I want minus value. Then we will get the left-handed.
You can do it that way. But if you're doing not left-handed, okay, you can do it that way.
Let's try.
How many of you are still trying? Can just raise your hand. Okay. Okay, we'll wait for 1 more minute, then we'll move to the solution. Shall we move to the solution now?
Yes, sir.
0.859, 0.899, 0.899, 0.10, 0.899. Okay, there are many 0.899. Let's see if that's right or not. Okay, before that, anybody can like to tell me the approach, like for example, you are given over here left-handed, right? Not left-handed, but we already have the probability values for the left-handed. So it's easy for us to think it this way, that let us first find out the probability of all left-handed and then take a complement of it. It would be easier for us to solve it. Is this okay for all?
Yes, sir.
Approach.
Yes.
Okay.
Yes, sir.
Now what you are saying, the first thing, as I was saying, it is in two phases. I think someone was saying that he's solving it according to tree diagram. I think even the professor has solved it that way in some of the lectures. That the first initial thing what we are trying to do is that either it can be a male or a female, right? Now when we are saying 45% are female, so what is the probability that let's say the probability of picking up a female, let it be probability, the event be F, and the probability of picking up a male randomly, it is M. So what would be the probability of F? It will be simple 0.45, right?
Yes, sir.
And similarly for the male, probability of M would be 0.55. Now what we are saying, once you have done this, read the question very carefully. Among all the females, 9% are left-handed, and among all the males, 11% are left-handed. So what are we trying to say? Let's say we have for the first we have picked up is a female. Now once you picked up a female, there are, what is the probability that it will be a left-handed, that she will be a left-handed?
9%.
So
0.09.
0.0.
Exactly. So now let me move. So that is the basic idea what we have to pick up the data from the question. Now after that, it's very simple. We are trying to find out probability of L. So if you see the what we are mentioning out there, what are the given data to us? 0.55, this is 0.11 and 0.09. Given that it's a male, it's a left-handed, and given that it's a female, always be careful how you read this notation. Okay, then it be the conceptually it becomes very easy for you. Whatever is on the right side of the blank, it is given that it's a male. What is the probability that he's a left-handed person? Given that she is a female, what is the probability that she is left-handed? So if you read it this way, it becomes much easier for you to interpret what you are doing actually. So now we'll move to the formula part. So as I was saying, we are applying over here law of total probability. So probability of left-handed total, it can be either that I first picked up a male and then he is a left-handed, or because it's plus, because we are either this case can happen or the second case can happen, right? So in the second case, it can be that either the first whom we have picked is a female, and then she is a left-hander. So now as so it will, we can write it M intersection L and F intersection L. Now as we are saying M intersection L, I think in the first question also we said that these are not again independent events, right? Because it depends on us the probability if it's a male. For example, the male were 50, and then from that you are saying the left-handed are 25%. So then obviously it depends, the probability of left-handed depends on either you are picking up a male or a female, right? So these are not independent events. So we will be doing probability of M into given probability of M. What is the probability of left-handed, which is already given to us 0.11. All the data are given to us. We just need to calculate it. And then we are, because we are finding it out for not left-handed, we'll take the complement of probability of left-handed. Is this clear to all?
Yes, sir.
Yes, sir.
Okay.
Hello, sir.
Yes.
Sir, my answer is only 0.8, not 0.899. So it is correct.
See, it depends on the question. You have to be very careful while you are means in exams. There it would be properly mentioned that you have to write it to 2 decimal places or 3 decimal places. So if it's given to for writing out to 2 decimal places, then maybe if it doesn't fall in the range, because your answers would be checked automated way, right? So even if you are right, you may lose mark. So be very careful how many decimals you are taking after whatever algebraic manipulation or algebraic calculation you are doing. Read the question very carefully, that how many decimal places close to they're asking for.
Okay, sir.
Okay. Okay. So this is a prelude to question number 3. this is kind of a bit tricky. So be careful while reading the question and analyze it properly.
Sir, are those two events independent to each other?
I'll not be opening out the answer as of now. Just whatever you feel, just type it out. Okay. We'll move to the solution. Whatever, just analyze it. Whatever we have done till now, 2 questions, and accordingly think what can be the answer. All done, or are you anyone still trying or brainstorming?
Sir.
Shall we move to the solution part? Okay, now whatever will, before we move to the responses part, just tell me maybe whatever approaches do you think, just anybody volunteer, just if you can explain it.
Sir, I have done passing section 1 is 0.8, not passing section 2 is 0.1, 0.8 into 0.1 plus 0.2 into 0.9.
Okay, and
Sir, I have done 1 minus by complementary probability 1 minus 0.2 not passing in section 1 and passing in section 2 plus not passing in section 1 not passing in section 2 and not passing in both.
Okay, see, first thing we are saying that let the probability of passing in section 1 be S1 and the probability that passing in section 2 be event in be S2. Okay, so what are we trying to find out over here? It is S1 intersection S2. Is this clear to all?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
now now if you're trying to find out S1 intersection S2, what are the possible formulas do you know when you are trying to find out 2 events and both has to occur? Anyone?
S1 into S2.
P probability of S1
Multiplication
into
form,
probability.
multiplication rule.
If both
Yes.
are independent, we can
Yes. Multiplication rule.
Okay, there are 2 ways to do it. One is multiplication. We can do probability of S1 into probability of S2. And the second way can be that we will take, if these are dependent events, then we will take, let's say, probability of S1 into given probability of S1. What is the probability of S2, right? This is what we have been doing till now, right? When they were not independent events. For example, let me move to
Sir,
that last
another way is using that or that.
no, over here we are having just 2 events, right? We are not using that was total probability. For example, this is a probability of M and L. You can just replace it by S1 and S2, right?
Yes.
So what this is another formula we can use, right? Probability of S1 probability of S2 given S1 has occurred. This
Yes.
first word before plus sign. If these 2 events are dependent, this is what we used to do for dependent, right? And if it's independent, as I said, you can directly do probability of S1 into probability of S2. Is these 2 approaches clear?
Yes, sir.
Yes, sir. But they have not mentioned which is whether it's dependent or independent.
Who is this? What's your name? Like, who was talking?
Sarvani, sir.
Okay, yeah, you are actually right. This is what we are trying to find out. Means wanted you to all know that as it is not explicitly mentioned in the question, never assume anything that it is independent. There can be some people who will say that, oh, okay, passing in section 1 doesn't matter, passing in section 2, so we can take it as independent. Never do that unless it is explicitly mentioned in the question. Don't assume anything. So
So in kind this comes from what should I assume? Just like I assume here independent event. So what approach will be the right?
no, you will not assume it's an independent event. That's what I'm saying.
Okay. Then
Don't assume anything. You can see the slide, right? Solution slide. That we don't have the conditional probability. This problem is not fully specified. So the purpose of this slide was just to make you alert that never assume that both the events are independent or dependent unless it is explicitly mentioned to you in the conditional questions. Okay. As we have not been given, once we will only have that probability of passing in section 1 and probability of passing in section 2. But once let's say, what is that means passing in section 1, what is the probability of passing in section 2? This conditional part we don't have any data for it, right?
Yes, don't have data.
So only way we could have solved it was that assuming it to be independent, but we have not been mentioned in the question, so it's not the right approach. Okay. Okay, we'll move to the next one. I think, okay, before that, let me see the responses. What was the responses for the last question? Okay, people have actually got answers. Okay. Okay, is this clear now to all? The prelude part?
Yes, sir.
Okay, so just, sorry.
What is the answer for this?
It's an undefined question. It's nothing. We won't have an answer for it. Just to make you alert that never assume anything from the question. Be very. Yes.
We can try this question by complementary method. That not passing in section 1.
Yes.
And passing in section 1. It could be the answer.
You are saying that you will find out what is the what is the ultimate thing you are finding out, that passing in section 1 and passing in section 2, right?
Yes, sir.
Then what is the formula you are using for it?
And minus passing in section 1 into passing not passing in section 1 plus sir, it's a complementary method that we assume that a person which passes in section 1 but not passes in section 2, and then sum up with not passing in section 1 but passes in section 2, and then sum up with passes in.
That is the thing we are saying. Now let's see, if I would have given independent, these two events are independent, then would the answer be same? It would be 0.8 into 0.9, something 0.72, right? So that is what you are saying, that we will not assume anything. Yes, you are right, you can do it that way, but then you are assuming some certain conditions, right? That's what the main motto of this question was, that whatever is given in the wording, only follow that. Don't assume anything extra. I'll show you a modified version of this. That is the next question. Just read this. Okay, so this is the modified one. I think now you can solve it, right?
Yes, sir.
Yes.
Be super fast. All 26 should answer this in 30 seconds. Still for this also 16 people, others. Okay, so we'll move to the solution. Okay, some people have also deleted the responses. No. It didn't. Okay, so let's move to the responses. 0.72 per. Yeah, actually this 0.98 is answer. Who is this one? I think 2 people responded 0.9. Who are those? Yeah. Okay. See,
multiplication.
Yeah. Sorry, can you come back once more?
Sir, it will be simple multiplication. Right.
Okay. So see over here, as I said, now we are given the same question. The question is still now the same, but the hint has been changed that we are using independent. So you can say that passing in section 1 is independent event of to passing in section 2. Right. So what happens? I'll tell you the solution. Maybe that would make it more clearer. See, as I was saying, event 1 can be, and what we are asked is event 1 intersection, and stands for intersection. Right? Event 1 intersection event 2. Now, as we are saying it's independent, so we can just multiply probability of event 1 into probability of event 2. Anyone in doubt?
No, sir, it's clear.
Okay. So this way you'll just find it out. 0.8 into 0.9, that is 0.72. Okay for all? Anyone still any doubt, or shall we move? Just see the solution slide. If you have any doubt from this part, you can ask me. No doubt. At this part, you see, this is what for the conditional part you write, right? When it becomes independent, we are no more depending on probability. Can you see my cursor, right? Probability of event 1 given event 2, that automatically becomes just probability of event 1, because these are independent events, right? So that's why you can multiply directly. Okay. So it will be just 0.72, not 0.98. Okay. So this one. Can you see the next question?
Yes, sir.
So sir, correct answer is 0.72, na?
Yes, it's 0.7.
Oh.
People who have given 0.98, did you understand how it's 0.72? Because it's just independent, we'll not find out the conditional thing. We'll just multiply both. Okay, then we don't just try this. This question you all should do it correctly, because I think we have enough discussed whatever needed for this question. Just read the statement very properly and try it, solving it. Everyone should attempt this, guys, and I hope all would give the right answer for this. Anyone, any difficulty how to solve this? You can ask me, but still, please try to solve this. At least 70-80% of the class should answer this. If you're not understanding, please ask, but please solve it. Still 8 or 9 are left. Please solve it. All done or still anyone trying?
Done, sir.
Okay. See the responses. Just give me a second. 5.14. This one is the right answer. Who gave this 5.14? First thing is we are trying to find out probability of P, right? Sorry, the value of P. Is that clear to all?
Yes.
Okay. So first. Okay, so those who have given this 0.57, I think Hughes Chunk has given 0.57. Like, how did you do it? Can you tell just? There's people who have given 4 and 5.14. Okay, so there's one possible answer, 0.57. How did you approach to this?
One intersection 2 union 1 intersection 3.
1 intersection 2 union 1 intersection 3. Correct. That will give us the probability of pass, right?
Sir.
Okay, so let me move to the solution part. Whatever you said is okay. This one intersection, section 1 pass and section 2 pass. Then the OR part that is the positive or the union, and then again 1 intersection 3. So now can you write this A union B part? Can I write it as normal just X? Sorry, A intersection B part. Can I write it just as X? And then this 1 intersection 3 part, again I can write it just Y. So can we will this convert into X union Y? Because X or Y it will be, right? Either this total event would happen section 1 pass and section 2 pass, or section 1 pass and section 3 pass. So the whole event I can take the top event that section 1 he has passed in section 1 and section 2. I can take all together as a single event, let's say X, and passing in section 1 and section 3 as Y. So we can write it as either he's passing means this whole total probability of passing can be written at X union Y. Is there any doubt in this?
No, sir.
Okay. Okay. Now what we are doing is when we are writing it X union Y, what's the formula for any A union B? How do we mention it? It's either means probability of A plus probability of B minus probability of A intersection B, right?
Yes, sir. Yes.
So when we are writing it, probability of A, that is sorry, probability of X, if you have taken it as X, then it is pass 1 and pass 2. And if it is probability of B or Y, whatever it is, then it is probability of pass 1 and pass 3. Now when we are saying A intersection B, then it will become pass 1 and pass 2 and pass 1 and pass 3 also. Means he has passed in all the 3 subjects. Isn't it?
Yes, sir.
So that is what has been given, pass 1 and pass 2 and pass 1 and pass 3. It becomes equivalent to pass 1 and pass 2 and pass 3. And so as we have been, I think, already mentioned in the question that we'll be consider using independence, right?
Sir.
So automatically A intersection B intersection C becomes probability of A into probability of B into probability of C. That would be P into 1.4 into 1.3. That comes out to be P by 12. Now what is given to us, probability of only that is event X, or you say event A, whatever, that is he has passed in means passed in first section and also passed in second section. That has been given to us P by 4, correct?
Sir.
And similarly passing in, this is means we are finding out probability of A plus sorry, and probability of B individually. So this is P by 4 and P by 3. And if we just put it in the formula, this is this pass probability of pass has been hiddenly mentioned as what? A union B, where now A becomes what is my A? That is probability of passing in 1 and probability of passing in 2, and B is probability of passing in 1 and passing 3, right?
Sir.
And this probability of pass comes out to be 1 by 3. I think that is mentioned in the question, right? So it's 1 by 3. So there is just normal algebra, what P value comes out to be through 2 by 3. Is this clear to all? It's just that we have assumed that whole event pass 1 and pass 2 as a simple normal one single event, so that algebraically we don't get confused, right? Yes.
So even though it's mentioned that the elements are independent, the reason that why we used minus P pass 1 and pass 2 and pass 1 and pass 3 was because we were taking union of pass 1 and pass 2 and pass 1 and pass 3. So that's why we have to subtract that, right?
Yes, because already we'll have
pass 2 and pass 1 and pass 3. Those two events are not independent.
Sorry, pass 1 and pass 2.
So pass 1 and pass 2, if we take that as event E, and pass 1 and pass 3, if we take that as event F, then event E and F are not independent, but pass 1, pass 2, pass 3 individually are independent.
Okay, just tell me, how did you find out this probability of pass 1 and pass 2 to be P by 4? How did you get this?
Sir, because they are independent.
That is 1 intersection 2. How did you find out? How did this P by 4 come in?
Into 1 by 4.
Sorry?
So P into 1 by 4.
Exactly. When do you do A intersection B as probability of A into probability of B?
Because sir, P1 and P2 are independent.
Exactly. So all the events are independent, right? It's not that means event E is also means whatever is inside the event E, that is two events, right? Means
Yes,
if
sir.
you're A intersection B, so they are also independent. That's why you could find out P by 4, right?
Yes, sir. Yeah, I got that, sir. But sir, E and F are not independent. E and F are dependent on each other, right?
E and F are dependent.
Yes.
There is no dependency, right? Either this event will happen or that event will happen. It is not condition.
Achha.
Either you will pass in, means either this event can happen, that is pass 1 and pass 2, or
Yes,
it
sir.
will happen pass 1 and pass 3, right? Independency, we'll check it when we have a condition. Let's say, like in the first case, we are trying to find out that pass 1 and pass 2. That is, I have passed in, means I have passed in the first section. Then what is the probability that I will also pass in the second section? So that's why, because they're independent, we have just multiplied them. But this is altogether different event. This is altogether different event. But as for the both the events, we have a pass 1 section. So there will be some common parts. So we have to take the according to set theory, we can do it A union B, that is A plus B minus A intersection B, right?
Yes.
Because we already have a pass 1 common in the other cases. If you would have seen, let's say we were doing male where we were doing male and left-handed. It was probability of male and left-handed plus probability of female and left-handed, right?
Yes, sir.
There is no common part. Over here we have a common part, that is pass 1.
Okay, yes, sir.
Is this clear to you?
Yes.
Okay. Okay, so from here on, Farhad will proceed with the session.
Okay, so good evening, everyone. Okay, now we have question number 4 here. Okay. Sorry, you're not audible. Am I am I audible?
Yes, sir. Yes, sir.
Okay.
Yeah.
Somebody is trying to ask anything?
Sure, actually his mic is.
Yeah, I think his network is.
Yes, you are. Oh.
Sorry, there's some issue with your network. You're not audible. Whoever this is, you're not audible. Okay, in the meanwhile, you others can solve this question.
Hello, am I audible?
Yes, you are audible.
Thank you.
Done, sir.
Okay, we'll wait for a few more responses. I've only got 12 of the total 27 responses. Are others solving this?
Done, sir.
Okay, 13. Let's wait for a few more responses. Those might be solving. We have not even got half of the responses now. It's around half. Okay, 2 more minutes for this question, then we'll start discussing the solution. Is everyone done with the solution?
Yes, sir.
Anyone solving and
Yes,
want
sir.
me to wait a while? Okay, I think we've given enough time for the question. Now let's come to the solution. Right. So let's read out the question first. What we have been given is that we have a manufacturing firm and there are 3 machines, machine 1, machine 2, and machine 3. Okay, now it's what the other information that has been given is that the machine 1 makes 25% of the total screws, and machine 2 makes 55, and machine 3 makes 20% of the total screws. So suppose if I have 100 screws, out of the 100 screws, 25 screws will be from machine 1, 55 will be from machine 2, and 23 will be from machine 3. So that's what it means by giving these percentages. So we know how to convert these percentages into probabilities. 25% will be just 25 over 100, 55%, 55 over 100, and 20% over 20 over 100. Now, what else we have been given? Let's move ahead to the question. It's known that it's known from the past experience that 1%, 3%, and 2% of the screws will be defective if made by machines M1, M2, and M3 respectively. Okay. Now, if we have machine 1 and it makes 25% of the screws, of the total screws that it manufactures, 1% of those screws will be defective. And similarly for machine 2, it is going to be 3%, and for machine 3, it's going to be 2%. Now, what the question has asked is that we choose a random screw at random. We randomly choose a screw from the total screws, and we have to find the probability that it is defective. Okay. Now, we have to list out all the cases in this question, right? Because we can get a defective screw that might be made by machine 1. We can get a defective screw that might be made by machine 2, or we might get a defective screw that will be made out by machine 3. So these are the 3 cases that we need to handle in this question, because there is no other way. We know that there are screws that are only manufactured by these 3, and we know that if we get a defective screw, it's going to be from one of those machines. Now let me just share my screen and yeah. Is my screen visible to you all?
Yes, sir.
Yes.
Okay. Now going to the question, what it has given us is that we have 3 machines, right? In a company, we have 3 machines. Let's look at this question pictorially so that for better understanding. We have 3 machines. This is machine 1, machine 2, and we have machine 3. Okay, machine 1, machine 2, and machine 3. Now, we know that 25% of the screws come from machine A. So what will be the probability that a screw will be from machine A? 25 over 100, right? Yeah. And from machine 2, it will be 55 over 100. And what will be the probability that it will come from machine 3? It will be 20 over 100, right?
Sir.
So this is what I am listing out right now is just what has been given in the question. Now, we know that what we are dealing with is the defective screw, right? Defective screw. So what is the probability that the screw will be defective, that it was manufactured from machine 1? That has been 1%, right? 1 by 100. And what is the probability it will come from machine 2? 3%, that will be 3 over 100. And similarly for machine 3, it's going to be 2 over 100. What I have done up to this point is that I just listed out what was given in the question. Any doubts with this? Anyone?
No, sir. No.
Okay. Now what we have been asked is this. We have to find the probability that the screw will be defective, right? Now, how many ways do we have that screws will be defective? I'm not talking about TNC here. I'm just talking about how many ways. Either it will be from machine 1, right? Or it will be from machine 2, or it will be from machine 3. From the 3 machines, like if we get a defective screw, we are certain that it will be from either of these 3 machines, right? Now, what will be the probability that the screw is defective that it came from machine 1? 25 by 100.
0.25 into 0.01.
Yeah, 1 by 100, right? Yeah. So either we will have this, or what might be the case that it came from machine 2. So what will be that probability? 55 by 100 into 3 by 100, right? Yeah. Or what else can we have? We can have that it came from machine 3, right? Yeah. So 20
Yes.
by 100 into 2 over 100. So these are all the possible ways, probabilities in which we will get a defective screw, right? Yeah. Now, solving this, it will be 25 over, right? This will be, I think, 165 over this. And this will be 40 over. Now, when we solve this, just let me solve this. It will be 20, yeah. Just a moment. 25 plus 165 plus
2300.
So it comes out to be 230, right? And divided by 1, 2, 3, 4. No, when we solve this is obviously going to be how much? 0.023.
0.023.
Yeah. So that is the solution for this question. Now that I think this is clear with everyone. Anyone has any doubts in this question?
No, sir.
Okay. Now let's have a look at the responses. What you all have responded with. Just a moment. Yeah, the screen is visible. Now let's see. And the responses 17 out of 0.023. Okay, we've got quite 1, 2, 3, 2 solutions, I believe. So for those who have got otherwise, yeah, one more is in 0.23. If someone has got this 0.219, just be careful. I don't know how you approach this question, but if you are making too many round offs, you might be getting 0.19 because of that as well. So be careful, because the question, there are certain ranges that the question accepts answers in, right? So this was for this question. Now let's move ahead to the next question. So this is just how this was defined. This is the solution that we just discussed right now. Anyone wants to read this? This is just the definition. Event 1 will be either it will be defective from first or machine 2 or machine 3, right? That's just what we saw right now. Machine 1 defective given machine 1. That's what we just now solved. Okay, to the next question. Okay, this is the next question. The previous question, as you can see, that we solved using total probability rule. Okay, what we did in that question, that was total probability. Now for the next question, we have given you a hit, go for Bayes rule in this question.
Done, sir.
Okay, we'll wait for a few more students to solve this. We've only got 9 responses. Let's just wait for others. Two more minutes and then we'll start discussing the solution to this question. So everyone, those who are solving this, hurry up, get it. Okay, now coming to the solution for this question, I'll start discussing the solution. Now, what this question states is that we have a population, okay? In that population, 45% of the population are female and the remaining 55% are male. Now, what else we know is what we have been given is that of all the females, 9% are left-handed, and of all the males, 11% are left-handed. So of all the males, 11% we have left-handed, and of all the females, 9% are left-handed. A person is now randomly chosen from this population. What the question now has asked is, if the person is left-handed, we know that the person now we've chosen is left-handed. What is the probability that the person is a male? We know, like, one person we have chosen from this population at random, and we know that person is left-handed. What is the probability now that he is a male? Okay, now if the question was asked that if the person chooses, if we have got a person, what is the probability that he will be left-handed, then we will go for total probability. But since we have been asked that, we already know, we know the end result, we know what we have at the end, that the person is left-handed, we have been given that. Now what we have to go is, we have to go back and see what is the probability that the person is male. To explain, to understand the question better, let's have a look at this. Can you all see my screen?
No, sir.
Is it visible?
Yes, sir.
Yeah.
Okay. Now, just a moment. Again, what we have been given is that in a population, it will either have males or will either have females. That's the assumption for this question that the question has stated. Now, what we have been given is either we'll get a female or we'll get a male, right? What is the probability that a person will be female from this population? That is 45 over 100, because we have 45% of the population as female. And what is the probability that male, that it will be 55 by 100, right? This is now what we are dealing here is left-handed people. Okay, left-handed. Now, what is the probability that a person is female, given that a person is female, that she is left-handed? 9 over 100, right? Because of all the females, we have been given that 9% are left-handed, and of all the males, 11% are left-handed. Okay. Now, of course, this is we are going to use Bayes' theorem for this, but let me just give you a better explanation for this question using Bayes theorem only. What is our probability basically? Probability of an event A. How we define probability of an event A? It's favorable cases over total cases, right?
Yes, sir.
Okay. Now what we will do is basically in Bayes theorem, that's what we use basically in Bayes theorem, but we just sometimes, because of the formula mentioned, it's like this: A given B multiplied by something and divided by a lot of stuff. We just tend to overlook this, that the basic formula for probability is this. This is what we have in Bayes theorem as well. How? Now what is our favorable case in this? What is a male? This is our favorable case, right? Yeah. So it will be, what is the probability for this? It will be 55 by 100 into 11 over 100, right?
Yes, sir.
What are our total cases? What are our total cases? That the person is left-handed, because we are dealing with the left-handed, right?
Yeah,
It will be either the person is a male and left-handed,
yeah,
or the person is a female and she is left-handed, right?
yeah.
This is basically what we have, right? This is our favorable case, that the person is a male and he is left-handed. And the total cases are that he is left-handed. And the total cases in which we have the person is left-handed, it can be either he is a male and left-handed, or she is a female and then she is left-handed, right?
Yes,
Now we can see
Right,
this will go throughout. This will go throughout. What we will be left with is this simple calculation now, right? So
Yeah.
55 cross 11, it gives us 605,
605.
right? Divided by 605 plus 45 cross 9, that is 405.
405.
So 605 divided by 1010, I think it has to be.
Yes, sir.
Yeah, 1010. Now solving this, 605 divided by 1010, it comes out to be 0.599. Okay,
Yes, sir.
so that is the solution for this. So this question, what I basically wanted to convey to you all is that we don't have to forget this. This is our basically, this from this we have all like come to this Bayes theorem, whatever we have started from this only, right? Probability of an event is the favorable cases for that event divided by total cases. Now if we were to look at Bayes theorem, this is basically Bayes theorem only, right? This is Bayes theorem. I've just substituted the values now here. If you would substitute the values in Bayes theorem, probability of A given B into probability of B or whatever it is, you will get this only, right? So what I have tried to show you through this question is that what probabilities that we are dealing with even in Bayes theorem, it's still favorable cases over total cases, right? So I hope everyone is clear with this question. Any doubts in this question?
No, sir, not clear.
Okay. Now moving to the next question. Second structure. So just the responses we'll see. That's 0.599. Okay, most of you have got this right. That's a very good thing. Now, what this is just what we just explained. It's just mentioned it here. Okay, 0.599 is the solution. Probability of male and left-handed, or probability of female and left-handed minus probability of male and left-handed. That's it's from one of the questions that Raj Kishore explained previously. This is how they have done it. But Bayes theorem, you can approach it like that as well. Okay. Now to the next question. Now, this is the question that I was talking about. In the last question, we were given that what is the probability that the screw is defective, right? It was up to this one only. Right here, can you see my cursor?
Yes, sir.
It was only up to this point. If a screw is chosen and random and found out to be defective, what is the probability, right? Find the probability of the screw being defective. So it will be either from all those three machines as we just saw. So it was total probability, like we were getting from all the total, whatever we had. So we used total probability. Now, we didn't know that question, we were not given that the screw is defective, but this time it's given that the screw is defective. Find the probability is made by machine M1. Okay. Now, all take your time to solve this. Okay, so everyone just hurry up a little, 2 more minutes, and then we'll start discussing the solution. Okay, I see a lot of people posting their solutions in the chat box. Are you people not able to join the periodic sessions? Periodic. Because I just saw it at randomly. I wasn't noticing that some people were typing their solutions in the chat box. It would be better if you could join those periodic sessions. The code is on the top right corner and post your solutions there. Okay, getting to the solution from this question now. Let's see. This is the question we solved, the same question, the pattern, but what they've asked that is different. What it's again given that we have 3 machines in a manufacturing from M1, M2, M3. 25% of the screws are from M1, 55 from M2, and 20% of the screws are from M3. So what else that from the past experience, it's known that 1% of screws from M1 are defective and 3% from M2 are defective and 2% from M3 are defective. Okay. Now, what is given that if we chose a screw at random and it's given that the screw is defective, the screw is found out to be defective. Now, what is the probability that it was made by machine 1? Like previous question we saw, we will again use the same question, concept. This is Bayes rule basically. So let me just share my screen so that we will be able to look at this question in a better way. Okay, is it visible now?
Yes, sir.
Now, getting to the question. Again, we have 3 machines, right? M1, M2, and M3. So M1, M2, M3. The M1 25%, so that will be 25 over 100. It will be 55 over 100 that is given, and 20%, yeah, 20 over 100. Now it is known that we are again dealing with the cases where the screws are defective. So what is the probability that the screw is defective that it came from M1? 1%, 1 by 100 basically. From M2 it will be 3%, that is 3 over 100, and from M3 it's 2 by 100. Okay. Now, just as we discussed in the previous question also, like getting to the basics of, not forgetting what the basics of probability where we got it from, that is probability of A is favorable over total cases, right? The cases in which our event is occurring. Now, what are our total cases in this? Total cases is that a screw is defective indeed. So that we just saw that what will total cases will be either the screw is defective, machine 1 made it and it's defective, right? Or what can be the case? Machine 2 made it and it's defective. Yeah. Or what else? Machine 3 made it and it's defective, right? Yeah. Now, in this case, what are our favorable cases? What we have been asked. What is the probability that it was made by machine 1? So this one is our favorable case, the machine 1 case, right? So it will be 25 over 100 into 1 over 100. So we'll see this all will cancel, this all will cancel, this all will cancel. So what we are left with is basically this 25 over 25 plus 165 plus 40. So how much it comes out to be? We'll see. 25 plus 165 plus 40. So it comes out to be 25 over 230, I think. So 25 divided by 230. it comes out to be, just a moment. Okay, so this comes out to be 0.108, or if you want to round it, what did the question say? Machine, okay, enter in decimal. Okay, if I will round it off, so we can write it as 0.1109. Okay. Now, what we did in this question is same. We approached this question in a similar manner that we approached the previous question, right? We had been given an event. We were told about the end result. End result we knew that the screw is defective. We first chose a screw. We knew at the end it's going to be defective. But what it has asked is something in middle. One middle, what it asked, what is the probability that it is defective? That we know that is given, the screw is defective. But what is the probability that it came from machine one? So favorable, what we are favored there is machine one. And what are our total cases in this? That is basically all the cases in which the machine, the screw will be defective. So this is nothing, this is just like, you know, the formula for this Bayes rule. You just have to substitute this here. What I want to give, what idea I want to give you through these questions is to visualize how this is related to the basic definition of probability. Any doubts in this question, anyone?
No, sir.
Okay.
Now it's clear. I was not able to understand the Bayes theorem before, but now I can understand.
Okay.
Excuse me, sir.
Yes.
If it can be asked that all are defective, then we have to
Yeah, we
all
just solved
defective.
that. Yeah. Did you join the session now, or you were in the session before as well?
Yeah. I'm from starting once.
Oh, you're from starting. So there was this question in which we saw that, oh, defective.
Yeah.
What is the probability that it's defective? I think it's
But
here.
according to you, sir, all the defective items from the machine 1 and machine 2 and machine 3, that will be the favorable to the total favorable outcomes.
Okay, so in this question, what we have in that question, these are basically two different things. In this, what we were doing is that is basically Bayes theorem, but this we're not dealing it in Bayes theorem, because we know what at the end we are getting, right? When we know what
So
at the end,
I'm getting all these things, but your approaches is too pretty than before, and I'm going with your approaches all in further. So I want just ask that all defective screws from machine 1, machine 2, and machine 3, then we would be go with the defective total defective divided by the total sample
right?
species.
What
Yes,
you're
sir?
trying to say is that it will be 1 in that case, right?
Yes, sir.
So of course it will be 1 when you are given that the screw is defective. It will be 1. You are given that the screw is defective. In this case, I was dealing in the cases that I have been given that the screw is defective. Of course, it will be defective. Then it will be 1, because we are given that the screw is defective, right? If a screw is chosen at random and found to be defective, what is the probability that it is defective? 1.
Yes.
Okay. To the next question now. So this is just the solution to this question, if anyone wants to have a look. Okay. Okay, this is the question, I think. Were we solving this question? Yes. Okay, this is the next question.
Okay. Be the event and the sum of the outcomes of the rolling die pair dice is 7. And C be the event that the sum of the out. I'm so sorry.
Done, sir.
Okay, we'll wait for we've only got 3 responses right now, so we have to wait for those as well. So okay, it would be better if you could, if you all could just mention your names along with what answers you typed in. Okay, if you want.
Sir?
Yes. Yes.
Yeah. Can you please say what is meant by mutually exclusive events?
Okay, mutually exclusive events are those events that cannot occur simultaneously. Okay, so taking an example, if you toss a coin, okay, can you get head and tails at the same time? No, you will either get a heads or a tail, right?
Yes.
Such events are called as mutually exclusive, the events that cannot occur at the same time simultaneously. Okay.
Okay. Thank
So their intersection, of course, is going to be 5, 0, right? Nothing.
you. The mutually exhaustive means?
Mutually exhaustive means that if we have mutually exhaustive events, what it means that we get the entire sample space. Suppose if we have all the events, say these, when you toss a coin, what events do you expect? Either a heads and a tail, right?
Yes.
So what is our sample space? Heads and tails. So these two events are called as mutually exhaustive because when we take them together, we get the entire sample space, right?
Yes.
So these are called mutually exhaustive. They exhaust the sample space. You get the entire sample space, in other words.
Okay. Thank you.
Sir, it's a multiple choice question.
Yes, it's a multiple select question. Yes. You can have a single, only one answer is might be correct, but it is a multiple select question.
Answer.
Okay, let's see. 17 responses were received for this. Now let's see the setting sheets. A, D, A, C, C, A, C. So we have a conflict between mostly AD and AC. Now let's first look at the question. Suppose we rolled a pair of fair die. So we have rolled a pair. So we get 36 outcomes in total. So that each of the 36 possible outcomes are equally likely. Okay, the dice, in other words, the dice are unnice. Let A be the event that the sum of the outcomes of the rolling the pair of dice is 6. Okay, and B be the event that the sum of outcomes of rolling the pair of dice is 7. Okay, let me just stop at this point. Can A and B occur together?
No, sir.
No, sir. So definitely they are mutually exclusive. We don't need to, like, we can do other ways. We will find A and B. Now then we'll see what is their intersection. Definitely their intersection won't be common. We won't have any common intersection, right? So from there we can also see they are mutually exclusive. But logically seeing, this is always going to be mutually exclusive. They both cannot occur at the same time, right? So option A is correct. Okay, now B be the event that the sum of outcome of rolling the pair of dice is 7, and C be the event that the sum of rolling of the pair of dice is even. Okay, choose the correct statements from the following. We have just looked at option A. Now see, this is A. Basically, sum of the outcomes of the die is 6. This is our A. B is that the sum of the rolling of the die is 7. We can see clearly there is nothing common between A and B, right? A intersection B is empty set, right? So from there we can also say, yeah. Anyone was asking it out?
No, sir.
Okay. So we can see that A intersection B is empty. So from there we can also say that these two, when we know that from the definition of mutually exclusive, when the intersection of two sets is empty, the two sets are said to be mutually exclusive, or the two events are said to be mutually exclusive. From logically we saw that we cannot, at the same time, we cannot get a die to have a sum, a pair of die to have a sum of 6 and 7 simultaneously. So this is mutually exclusive. So A and C, we can see that A is contained in C, right? Right?
Yes, sir.
Is a even number. Sum is even number.
Sir, are you speaking something? We don't hear anything. Hello?
No, it's just disconnected.
Oh my God.
Am I audible now?
Yes, yes, yes.
Okay, okay. Sorry for the disturbance. There was some issue with the internet. Okay. Now, I don't know up to what point I was audible. So can you guys just say, confirm up to which point I was audible?
After we check the first option, you are not audible.
Okay, okay. So now we check the first option. We saw that it's mutually exclusive, right? Now coming to the second option, A and C are mutually exclusive. What it means is that A and C cannot occur simultaneously, right? By this option, that it means. But let's see what A is. A is the event that the sum of the outcome of rolling of the pair of dice is 6. And C is the outcome of rolling of the pair of dice is an event number. So clearly these two can occur simultaneously, right? Even if we see from this, A is this and C is this, A intersection C is not empty set, right? 1 5 is there, 2 4 is there, 3 3 is there, 4 2 is there, 5 1 is there. So basically A is contained in C only, right? A is a subset of C. So A intersection C will be A, right? So we can see that their intersection is not an empty set, and from that we'll say no, these two are not mutually exclusive. they can occur at the same time. Logically saying, they can occur at the same time. We can get a pair sum as 6, and that sum will definitely be even, right? So
Yes,
these
sir.
two are not mutually exclusive. Now A and B are independent. Now what is the probability of A and B? 0. Like probability of A and B, that is 0, right?
Yeah.
A intersection B. A and B, by A and B I mean A intersection B.
Yes, sir.
It's 0, but probability of A into probability of B, that is not equal to 0, right?
Yes,
Yes,
sir.
sir.
Since probability of A intersection B is not equal to probability of A into probability of B, what we can say?
They're not independent.
Yeah. Yeah. So A intersection C is basically A only, right?
Yes.
Yes.
Probability. What is probability of A? 5 by 6. What is probability of C? 18 by 36. What is probability of A intersection C? That is again 5 by 36. We can say that is clearly it's not equal to probability of A into probability of C again, right?
Yes, sir.
Okay. So any doubts in this question?
So can you explain independent?
Yeah, independent events are basically those events. Suppose if we have two events are said to be independent if like one event occurs and it does not change the probability, or it does not impact the probability of the other event happening. Okay. Hello, am I audible?
Yes, sir, you're audible.
Okay, so you have not covered week 7 yet?
So I have covered it, but I haven't understood this term, like how two events are independent. So can you in short tell me in this?
Okay, so what have you understand? Like you haven't understood anything about these independent events, right?
I have understood about the mutually but this independent sets.
Okay. So what when we have two events are said to be independent if one event occurs, right? It does not affect the chances of occurrence of the other event. Okay. Suppose we have this which example? Okay, we have this deck of cards. Okay.
Yes.
And we are doing it with replacement. If I am drawing out one card, I am then replacing it again. What is the probability that I will get an ace in the first if I draw a card? 4/52, right?
We are putting the card back.
Back, exactly. Yeah, I'm putting the card back. So it will be 4/52.
Yes.
So now I put the card back. Now what is the probability of getting me getting a king?
It will be same.
Same. So did the first event impact the other event?
No.
So such events are said to be independent. Two events are independent if occurrence of one event does not change or affect the occurrence of the other event. Okay.
Okay. Now I got it. Thank you.
Yeah. So I think this is the last question, I believe. Yes, this is the last question for today.
So the option for the last question are what? A and D.
No, that's only A, I think. What was A? We found out to be mutually exclusive. They were not mutually exclusive. They were dependent and they were also dependent, right?
Sir, please explain this independent term one more time.
Okay. So independent means if the occurrence of one event does not affect, like if we have two events, only we can define independence and dependence for two events. For others, they can solve this up to that point and explain this. So two events, like when we say something is independent of something, when we have two things, right? Two or more.
Sir, your voice is lagging.
Now it is clear?
Yes.
Okay, what we basically mean by independence, we have two events, two or more events are said to be independent. Let's consider the case of two events. Two events are said to be independent if one event occurs, okay, it does not affect the chances of the other event's occurrence. Okay, so suppose like I also said this example, if we have a deck of cards and we are taking out two cards, but the first card when we take out, we put it back into the deck again. Okay, what is the probability that I will get an ace? It will be 4/52, right? Because we have four aces. Now that I have taken out one card, I put it back. What is the probability that the second card I take out, it will be a king? 4 over 52.
Same probability.
Yeah, 4 over 52. Or suppose, let me say, what is the probability that I will get a diamond? It will be 13 over 52. So did the first event change the probability of the second event? It
No,
was
sir.
always going to be 13 over 52, right? The probability of getting a diamond, as we know, is 13 over 52. So such events are said to be independent. So the events that do not impact, that do not affect the chances of the other event, occurrence of the other event, such events are said to be independent. Okay.
Okay, sir. Thank you.
If we want to see it like another way, if we roll a dice twice, okay?
Yes, sir.
We will get an outcome on the first die, right? And we will get an outcome on the second dice as well. Okay, suppose we are rolling a dice twice, one after first, like one after another. Okay, will what we get on the first die determine what we will get on the second die? No, these are random. Like if we get 4 on the first die, any number can occur on the second die, right? 1 to 6.
Yes, sir.
So it does not change its probability. Whatever we get in the first die, it won't change or impact the probability of whatever we will get in the second dice, right? So
Yes,
such
sir.
events we call as independent events.
Okay, thank you, sir.
Yeah. Just one hint for this question. This is a simple conditional probability question. Simple. Two more minutes and then we'll start discussing the solution for this question. Okay, now let's see the responses for this question. 0.25, 204. Okay, we've got a variety of solutions. 0.102, 1029 seems to be the most common. Okay, 0.1029. Somebody has got the solution as 0.25. Can they please tell who got the solution? 0.25.
Sir, can I ask something?
Yes. Is it related to this question?
Not this question, but the before question that was written that use base theorem. In the exam is also that's written that use base theorem, because sometimes I'm not able to answer use it or not.
It won't be written that use base theorem or use total probability. That you have to figure out. That is basically the challenging part, a little challenging part, to figure out whether we have to use base theorem or total probability. So this is
that's the I'm asking.
No, that won't be mentioned. Use base theorem. It was just a hint. In exam, won't be given a hint.
Okay.
Okay. Now, who has got the solution 0.25? Can they please unmute, if possible? Okay. Now let's see what the solution. The solution for this question, in fact, is 0.25. That's why I was asking the person who got this. Okay. Now let's first read out the question. An urn contains a total of 10 balls. 10 balls, of which 3 are black and the remaining are red. So 3 are black and 7 are red. Suppose a sample of 4 balls is drawn. What we did is we drew 4 balls from the urn one by one without replacement, right? So this is what has been given. What is the conditional probability that the first, third, and fourth ball will be red, given exactly 3 balls out of the 4 in the sample spaces are red? Now we have drawn 4 balls, and what we have been given is that of the 4 balls, 3 are red. What we have to find out is the probability that the first, third, and fourth will be red. Only choice that, like, only restriction is the second ball can be black or it can be red. But what we have been given is 3 are red. Now let's look at the sample space. This is basically let A be the event that the first, third, and fourth ball are red, okay? And B be the event that in the sample of 4, 3 balls are red. This is what we have been given. So what we have been asked is probability of A given B. We have been given that of the 4 balls, 3 are red. We probability of A is let A be the event that the first, third, and fourth ball are red. That is what we have to find. Probability of A given B. We know the formula for that is probability of A intersection B divided by probability of B. Now for A intersection B, we have only one choice, right? Red, black, red, red. Because A intersection B means that the first, third, and fourth balls are red and 3 balls are red. So it is definitely second ball has to be black, right? Because 3 balls are red and first, third, and fourth ball is red. So first, third, and fourth balls are red, and we know only 3 balls are red, right? So that leaves us with this thing that second ball has to be black. Any doubts?
No, sir.
Okay. Now probability of getting a red ball, it's 7/10, right?
Yes.
Now probability of getting a black ball, it's again 0.3, and that is 3/10. What will be probability of A intersection B? That will be red 0.7, black 0.3, red 0.7, and 0.7, right? And probability of B, like getting probability B be the event that of the sample of 4 balls, 3 are red. First we choose 4 of 3 will be red. What is the probability of 3 being red? 0.7 raised to power 3 divided by 0.3, right? 4 of 4, first we choose 3 balls from the 4 balls. What is the probability that first ball will be red? 0.7. What the second ball will be red, or 2 balls will be red? 0.7 again. 3 balls will be red? 0.7, and 1 ball has to be black? 0.3. So when we divide these two, we get our answer to be 0.25. Okay.
Sir, how did we find B? Can you please explain that?
Yeah. So what is the probability of B? From the 4 balls, 3 are red, right? How many, like, of, sorry?
Sir, can you just solve it in the notepad, sir, in your normal notepad thing?
Okay. Just a moment. Is it visible?
Yes,
Yes,
sir.
Okay. Now, what we have that in the urn, there are 10 balls, right? Of the 10 balls, what we have, 3 are black, which implies 7 are red. Oh, sorry, red. 7 are red, right? Now, what is let A be the event that first, what is mentioned in the question, first, third, and fourth ball are red, fourth red, and B be the event that of 4 balls, 3 are red, right? This is what we have now. What we have been asked is probability of A given B, right? Probability of A given B. What is the probability that the first, third, and fourth ball will be red, given that of the 4 balls, exactly 3 are red, right? Now, what we are left with, probability of A. Probability of A. What is probability of A getting probability of getting a red ball? Sorry, probability of getting a red ball. What is the probability of getting a red ball? 0.7, right? Probability of red. What is the probability of getting a black ball? it's 0.3, right? So what then? What is probability of A intersection B? What is our A? A is that A is first, third, fourth balls are red. And what is B? 3 balls are red. Now we know that we have been given 3 balls are red, and A intersection B is A is basically first, third, and fourth ball are red. So one ball has to be black. The second ball has to be black, right? For A intersection B, A and B to occur, one second ball has to be black, right? What is the probability of black? 0.3. Okay. Now what is probability of A intersection B? Probability of A intersection B will be 0.7 red, black, red. This will be black, red, then black, red. Just remember. Okay, red and black, right? Since why is this probability not changing? Because it is with the replacement. With replacement, that is why this probability is not changing. We once draw a ball, we just put it back.
Sir, fourth one is also red, right?
No, sorry.
Fourth one is also red, right?
Okay, yeah. Sorry, that's a mistake on my part. Fourth one is also red, right? You understand that probability of red will always remain 0.7 because it is with replacement.
Oh yes.
It is with replacement, so these probabilities will not change, right? So what we get probability of A intersection B, it will be 0.7 raised to power 3 into 0.3. This much clear? Any doubts in up to this point?
No.
Okay. Now, what is probability of B? Probability of B. What is probability of B? What is B basically? 3 balls are red. From the 4 balls we have, 4 balls. Out of the 4 balls, we choose 3 balls that are red. And what is the probability of 1 ball being red? 0.7. What is the probability of second ball being red? 0.7. And probability of third ball being red? 0.7, right? And the fourth ball will be black. That is probability 0.03. 0.3. Okay. Any doubts in this?
Sir, please, probability of B, how is it is
okay,
possible?
4C3. Okay. So you are confused with this part, 4C3, right?
Yes, sir.
Okay. There, how many how many balls are we drawing?
4 balls.
4 balls. How many of those are black?
1 only.
3.
3 block. 3
3 red.
3 red. Black will be 1.
Yeah. So how many of these are red?
3 are red.
Yeah, 4 out of 4, 3 are red.
Yes.
How many ways can such be? Out of the 4 balls that we choose, 3 are red. 4 from 4. Yeah. And what is the probability of red? 0.7. 0.7, because we have 3 balls, we will get 0.7, and 1 ball is going to be black. Because of that, we get this as 0.3.
Sir, then we are selecting only 3 balls. Then why we are multiplying with 0.3?
No, we are selecting. What is B is 3 red balls. B is not 3 balls. B is 3 red balls. Out of the 4 balls, 3 are red with the probability of 0.7, 0.7, and 0.7. Of the 4 balls that we selected, 3 are red, right?
Okay.
And what is the probability? 3 balls are red. Now we have 3 red balls and 1 black ball, right? What is the probability? That is basically 0.7 into 0.7 into 0.7 into 0.3, right? From the 4 balls that we choose, we are choosing 3 balls to be red. We are choosing 3 balls to be red. That is basically event B. That is how event B has been defined here. Okay?
Yes, sir.
Okay. So just substituting it in probability of A given B, that is probability of A intersection B divided by probability of B. What is probability of A intersection B that we just found out? 0.7 raised to power 3 into 0.3. And what is this? It is 4C3 raised to power 0.7 raised to power 3 into 0.3. This will go with this. This will go with this. 4C3 is basically 4. 1 by 4. 0.25. That is the solution for the, sorry, 0.25.
Okay. But sir, when I see the solution, okay, this is easy. But when you start that, we're not able to understand the A and B, and the B thing is really tough to understand. What would be the B? But the solution is easy, like after seeing that. But when you solve B, but this is in suddenly count. The B part is really tough to understand. What will be B?
Yeah. So I understand, like, this might be a little difficult for you because it's a little hard on mind, right?
Sir, you told that this is a very simple question.
No, I told not that simple. I told you just have to use conditional probability because somebody might be getting to a Bayes theorem.
It's quite tricky question.
Yeah, it is a tricky question. But simple, I meant it's not like somebody, because I was not getting any responses, and the responses that I got, they were like too much deviated from what the solution is. So I thought somebody might be using Bayes theorem, somebody might have gone with total probability. So in that sense, I meant it's a simple conditional probability question, conditional probability only. Okay.
Okay.
This is a tricky question. Of course, this is a very good question.
Very tricky.
Yeah, you will expect like this. In this question, we use these 4C3 combination, right? You will deal with in the upcoming weeks. There will be some distributions, but like in the upcoming weeks, we will be dealing with these. Then when you will get back to this question, you will feel this question to be so easy.
Sir, this type of question will appear in the quiz 2?
I don't know. I have no idea what will be there in quiz 2.
Okay, sir.
Okay, so any other doubts?
No, sir.
Okay, so for others who have other doubts, we have those doubt clearing sessions in the day as well. And the problem is similar to this pattern only. We have solving sessions in the morning. They can join that as well. And in the evening, we have one doubt clearing session. Okay.
Can you just show this question? I'll make a screenshot.
Yes. Can you see the question now?
No, sir.
No, sir.
Now is it visible?
Yeah.
Okay. So the thing to these questions is how you can make out what is total probability, how the question is from total probability, or if the question is from Bayes theorem, or it is simple like conditional probability. In that sense, is to practice and do more and more questions. The more and more questions you do, the more you will get an idea if the question has been asked from total probability or is that been asked from Bayes theorem. Okay, because a lot of people, including myself, when I used to solve this, I used to get confused between total probability and this Bayes theorem. Okay, so just giving a little hint to how you can easily differentiate if the question is from total probability and or is it from Bayes theorem. If the end result has been given to you, okay, you know, suppose in this question, let me get here. Okay, so this question, let's get. I am choosing a screw. That is basically my event, right? That is what I am doing, right? And the end result, I know this screw is going to be defective, right? That has been given, right? The end result is given, found to be defective. I choose a screw and what I get at the end, that has been given to me. Okay. In such questions, go for Bayes rule. When you know what at the end, what you are getting, you have to find something that is in the middle, like machine 1. It came from machine 1, that was kind of in middle. You know what at the end you were getting, Bayes rule. Okay. Now to this question, the same question in which we didn't know what at the end we were getting. Okay. We were not given, in other terms, we were not given what we were getting at that. If the screw is chosen at random, right? What is the probability that is defective? We don't know right now. It is defective, right? So for this question, you will go with total probability. In that question, we knew, we were given that the end result is going to be defective. In this question, we have to find what the end result is going to be. Okay, so in this question, total probability. In this question, since we know what the end result is going to be, it is given. In this question, where did it go? Yeah, in this question, it is given the end result is going to be defective. Go for Bayes rule. Use the same similar concept in other questions. Okay, let's see, there was one more question. We'll use this same question. Okay, in this question, we know that the person is left-handed. Is given? We know the end result that the person we choose. Okay, the person is given to be left-handed. Okay, we have to find something in the middle, whatever that is. Okay, go for Bayes rule again. Okay, is that clear?
So I've got a different query. Like, can I ask it now?
Is this regarding what is the query regarding?
So basically, query was pertaining to one question we discussed in the morning today. Actually, this was pertaining to one graded question number 8, question number 10.
Graded question number 10.
Graded week 8, not I think 10 or 12. I think 12. So,
I don't think we discussed it in the morning. You might have discussed it with the Raj Kishore, I think.
Yeah, not with you, not you. What my question was, if, just for my understanding, if I calculate, say PB given A,
what is?
then,
are you referring to some specific question?
Yeah, I'm referring to question number 12.
Okay, just let me get there. Graded assignment 8.
Yeah, this is assignment 8, question number 12.
Okay, has the deadline passed? Not yet.
No, I'm not asking the question, the answer, or whatever. I'm asking something else. If you open it, I'll ask.
Okay, this is from this contingency table, right?
From no, that basically that red ball, sorry, the red T-shirt and the 2 shops.
Question number?
Question number, I think it was 12 or something like that.
Okay. Yes. I got it. There are 2 shops A and B selling T-shirts.
Yeah, right. What I'm asking is, so this question they have asked about what is the probability of the shop A given that it has 2 are from red.
Just a moment, I lost it. Just a moment, I closed it by accident. Just a moment, let me get back. Okay. No, I went to mathematics.
Yeah.
Week 8. Okay, I'm there. Yes.
Yeah. So the probability what was asked was, what is the probability of shop A given that both are from red?
If the probability, both the T-shirts purchased are red. Okay, and the probability that it
what is from shop A. I'm just asking if the question would have been, what is the probability that it is the probability this is red, given that it is from shop A. So I'm just reversing it actually.
Reverse what?
I'm given the given condition was not the given condition here is given that it is red. What is probability it is shop A? I am telling it is from shop A. Given it is from shop A, what is the probability it is red?
That is what is question has asked. What is the
question
probability?
No. Question has asked probability. What is the from shop A given they are red?
Okay. Yeah.
I'm asking. I'm asking that if I have to need to calculate what is the probability of red given that it is from shop A.
Okay, what is the probability? Basically, what you want to say is in this question, if both the T-shirts are purchased are red, and the probability it was purchased from shop A is whatever it is. Now you want to say if both the shirts are purchased from shop A, what is the probability that they are red?
Right. I'm just saying the opposite, other way around.
Opposite.
That can I say that to be in the denominator it will be P of A, and numerator P A given R1 R2 dot P R1 R2.
I don't know what your R1 is, but I don't know what your R2 is.
Say first R1 is the first rate, as R2 is the second rate. So, so I'm saying P R1 R2 given A. So P R1 R2 given A, I'm writing as P denominator it is PA and numerator PA given R1 R2 dot P R1 R2. Is it okay?
Okay, so this is a graded question. Wait just a moment. I didn't get your doubt at all. If you are saying that you want to say that if both the T-shirts are purchased from shop A, what is the probability that they are red? That is
yes. I'm giving you a formula. Is this just let me know it is correct or wrong? If it
Okay,
is correct
so
or it needs to be corrected.
if I tell you if this formula is correct, then you will know the formula for this question if that is incorrect.
No,
right?
that I have already solved. That one I have already solved. The
Okay, I
question
don't
is
know.
I have already solved.
I don't know if you have solved it correct, if your solution is correct. I don't know that right now. And I cannot discuss that as well. But if I tell you the other way, if I tell you what the other way it is going, then okay. If both the, I'll just give you a little hint, not much. Okay, I won't be able to, like I'm constrained because the deadline has not passed. And it's
No,
related
I'm totally asking a totally different question. I'm asking that if I reverse it, if it's in that this question is asking something else, I'm asking something else.
Okay.
So in that case, where I'm struck, I'm telling you, in this case, because I have used the branch, you know, A is one branch, B is another branch. From A, I can go to R1, R2, or I can go to R1, R2 bar, which is not R1, R2. For B also, I can go to R1, R2, or I can go to R1, R2 bar. So from that branch, I have used it and I have resolved that.
You just like for the second question that you are asked, you just have to you will be considered with, like you will be considered with one branch only. Okay.
Yeah, where I'm struck actually is I'm struck in the denominator part actually. Denominator PA. When I say PA, in other case, actually P R1 R2 I easily calculated because PA into P R1 R2 given A plus PB into P R1 R2 given B. In this case, PA, the probability of A, shop A. So
okay, just a moment. I want to write whatever you have because you are going too fast. I'm not able to follow it. Okay, just a moment. I will just write. Okay. Okay. What you are saying? Just
yes.
Yeah. Can you please?
What I'm asking is.
What is your R1 first?
R1 is the first red. R2 is the second red. Okay.
First shirt is red.
Yeah,
okay?
the first R1 is the first red and second one is a red t-shirt. R2 is the second t-shirt. Both are red actually. Both are red.
Okay, that is R1, R2. Okay. Now what else have you decided?
I'm asking that you need to calculate the probability of both are red given that it is from shopping. So the P R1, R2 are two red shirts. Yeah. Given that it is from shopping.
Okay, I proposed one of the both the t-shirts purchased are red. Okay.
Given that it is from shopping.
Okay, no, the t-shirts purchased are red. Both probability of red. Let me just denote R as both red. Okay.
Yeah, right. Okay.
Both red.
Yeah, that is better.
Probability of R because R1, R2 it's going getting a little confusing, right?
Okay,
it's a little hard on me. So we'll just deal with this probability R that both are red. And the probability if both t-shirts purchased are red, and the probability that it was purchased from shop A is 6/7. So
yeah, that part is already done, sir. That part is already you have done it. That they asked was P given P of A given R. They asked for the P of A given R. Yeah, that I have already resolved it. That is given to be 6/7. Yeah, this is already given. That is given already. PA given R was 6/7. They have already given. I was asking PR given A.
Yes, okay, that is what exactly I was telling you. What exactly I was telling you is PA given R, right?
Yes. This is 6/7 given. PA given R is given 6/7. Yeah.
See, most of why this question is asked because this is a pretty simple question. If we know what is A given R, right? This will be answered. But what is tricky about this question is that you have to see, have I been given PR given A or R or what has been given is PR A given R. Okay. That is what you have to basically, that is the point of this question. You have to figure out, am I given this or am I given this?
No, this PA given R is the first part. 6/7.
Like exactly. Like I had some doubts. Somebody might ask why if it can be PR given A. I don't know which one is right. I like until the deadline is passed. I don't know if
it is very simple. It is very simple mention now. Given it is from shop A. Given probability of what is the probability of shop A? Given they are red. So PA given R.
It is simple for it is simple for you to follow this, right? There are a lot of, trust me, there are a lot of people who are not who are confused with this. Is it PR given A or is it PA given R? That is my point. there are a lot of people who are confused in this as well.
Okay.
That is my point. Like you want to ask, is this PR given A, right? That is
No,
what
no,
you
no,
want.
I'm not. That is not my question. I have written I have written PR. What do you call R given A as P A given R dot PR. You can write that. You just let me know whether I have written it right or not. PR given, P A given R
intersection
into
A.
P A given R, not intersection. P. Achha, you are writing like this. Okay. So I am writing that as P A given R. P A given R into PR. Divided by PA.
PA. Like if you condense this, then you will get this, right?
Yeah,
this is
yes.
basically multiplication rule.
Yes, it's multiplication. So in the PA part, should I need to further break, or it is PA is directly okay?
You are saying this PA.
Yeah, yes.
Do you need to further break into what?
Yes.
What is A? What is A? Shop A. Why would
A shopping? A is shopping. A is shopping.
Why do you need to break it?
Yeah, I
further?
don't need. So that's what I'm asking. I don't need.
That's okay. This was your question. Do you need?
Yeah,
to
that's
break
question.
like,
Right. So I need not have to further break it. That's
no,
what I'm asking.
why would you need to? Because you are just concerned with this part in this, right?
I was concerned about the numerator is okay. That is okay.
Why I was saying that is like you said this is pretty simple. What you said is it is pretty simple that it is PA given R, right? But there are a lot of people that are thinking that this might be PR given A. Okay. So if I answered that part, it is A given R. So that would have given away the solution, right?
Understood.
For the people who have doubt in this, if I said this is okay, you are right in this, they would consider okay, this is wrong, right? So I cannot do that. Okay.
Thank you.
Yeah,
understood. I got my clarification.
Okay. Thank you. So any other doubts?
Sir, please show the solution part of the last question. I will take a screenshot.
Yes, definitely.
Others may leave.
Yeah, sure. The session had to be over before 43 minutes now.
Sir, just one, not any question related to this question. I mean, what are the solving that we did? Okay, it's a general operational part. So, I mean, I'm a working professional, so I mean, I don't get to chance to attend those practice sessions or some things that happens during the daytime. Okay, I mean, occasionally I get a chance to attend.
Sir,
do we find any kind of recording videos of those things available?
No. What we have, we don't record. Actually, we don't record those sessions. What is recorded are these sessions. These sessions that are held at these times. This is Solve with Us, basically open session and activity session. These are recorded and they are available on YouTube. The morning sessions, they are not recorded.
Sir, please show your written solution. I will take it again.
Okay, just a moment. That is from a different device. Just a moment.
So one more thing while you're sharing that, okay, just one another query. So, I mean, till week 6, like, the graded assignment solutions are uploaded, but not the EMQ solutions. I mean, week 6 onwards, we had a EMQ part. The problem is like the solutions are not uploaded. So, I mean, even the questions that we give answers, right, we get only the score. We don't get to know which is correct or which is wrong until we get the solution where we can compare ourselves. So I raised, I sent, I raised some couple of times things in the discourse as well to upload that, but I mean, it's been quite long time, like it's not getting uploaded.
So,
sir, please slide up.
Okay, sir. So, yes, sir. So what I will do is I will just run it through with the concerned team that is concerned for that, and I'll just let them know.
Yeah. Thank you.
Okay.
Sir. Yeah, thank you.
Yes, that is all I can do because I'm not confused. That's operational issues. Okay.
Sir, please slide up.
Yeah, I've done.
Yeah, because the problem is, I mean, I sent an email and also raised a couple of times a comment in the discourse. Looks like, I mean, I got a response saying that it will be uploaded, but doesn't seems to be actually happening. So I don't know whom else I can connect with that.
Okay, yes, definitely, sir. I will run your query to the instructor. Okay.
Yeah. Thank you.
Yes. Sir, please slide down. again more. Okay, thank you, sir.
Okay, so I'll be ending the session now.
Okay, thank you, sir.
Thank you, sir. Thank you for your
Goodbye.
time.
Yeah.
Bye.
Goodbye.
Thank you, sir.